So hello everyone on today's LOH, so LOH session 14. And today is 13th of March 2024. So in today's session, we are going to talk about Launchpad development since last LOH, a quick intro to Helm and Helm Charts, some Helm Charts basics. We will look at Helm Chart, so talk a bit about creating and customizing a Helm chart, and then we'll talk about other Helm functionality and some troubleshooting, plus any of your questions. All right, so straight ahead, going with general updates since last Launchpad, last LOH. We've had, as always, new stable releases for Launchpad charts, so Aragon Lighthouse, ProxyD, and so on. And we've also had new stable releases for Launchpad namespaces, so monitoring, ingress graph, gnosis, and so on. And since this was officially announced today, thank you, Billy, for the announcement, we have introduced Cello support for Launchpad namespaces, and we have a Launchpad chart to go with it. I think this was mentioned last session, but today it was officially announced, so reiterating that. All right, and as always, you can find our issues in GitHub, so please do file issues if you have any, and please do contribute. All right, so Helm and Helm charts. So Helm is a package manager for Kubernetes that simplifies the deployment and management of applications. It packages Kubernetes resources into charts, making it easy to share, version, and manage those deployments. The charts help define, install, and upgrade applications and are collections of pre-configured Kubernetes resources. Helm itself helps manage resource dependencies, updates, allows for rollbacks, and in general streamlines the application lifecycle. It also enhances productivity and standardizes deployment practices across different Kubernetes environments. So a quick comment about Helm and its previous iterations. So currently we're on Helm 3. Helm 3 was introduced in 2020. In Helm 3, the state of a Helm release is stored in the Kubernetes cluster itself, specifically within the namespace where a release is deployed. This is a major shift from Helm 2, and Helm 1, which used Tiller. Tiller was a server-side component that managed the state. You will see a lot of blog posts and just some negative press associated with Helm around security. This referred to Helm 2, where Tiller was basically a giant pseudo server. So just an authorization layer with a lack of access control, and which needed additional TLS certs to maintain for security. So that's gone. The security concerns and operations have been addressed, and operations have been simplified massively. And now all of the state lives in the Kubernetes cluster by default in Kubernetes secrets, but it can also be configured to use config maps and CRDs for storage. And we can look at how to find state later on. Now, in terms of how Helm compares to the rest of the ecosystem, it's really hard to even say much about this because there's no one specific there's not one-to-one comparison. So I'm just gonna briefly touch on Helm and customize and a few other comments, and then we can move on. But Helm is highlighted as a package manager that simplifies software installation lifecycle through charts and templates. And Customize is a declarative templating engine for managing Kubernetes configuration through customizations of base YAMLs. And Customize uses overlays and customization files. So if Helm is a package manager, Customize works off the concept of refactoring Kubernetes manifests. Helm also offers a repository for sharing and distributing resources, whereas Customize focuses on configuration management without a built-in repository system and instead relies on source control management like Git. So those two are the Helm and Customize are the two main options for users who are trying to manage their Kubernetes application and the resources associated with them. In the past, JSONet was used. So JSONet is a templating language and engine with an object-oriented approach that allows for complex and relationship-based templates to be created. I'm saying in the past because to use JSONet, there was a JSONet flavor specifically for Kubernetes called KSONet, which was maintained by the Heptio team, and they have stopped supporting that. I think the reason is as simple as they were bought by VMware. I wasn't able to track down the blog post that explains why they have stopped support for KSONet. I see Carlos typing. Would you like to comment on any of this?
I was going to ask a question.
Yes, I was just to answer you, and I was just plugging in APT, which I think is another take on configuration and deployment for Kubernetes. Didn't see yet, at least, as much community adoption, but I think it's worth taking a look. I think it's a reasonable project. Go ahead, Matthew, sorry.
No, thanks, Carlos. I was going to ask, so is there like, what do you call it? Like, which use cases would you use Helm versus Customize? Like, because that was a debate, or maybe not a debate, but discussion we were having last week is where should we use what for what purpose, in terms of how we manage things in our environment.
I'm going to attempt to answer that one, or to give a take on that one, and then I'll let Anna do the same. One thing you'll quickly run into while trying to build charts is that when you go the way of templating, you sacrifice code readability in the pursuit of trying to be dry, right? Like that, don't repeat yourself. It's very, very easy to end up with a lot of templating code which isn't readable at all. And it's very hard to make sense of. It obscures that. So Customize tries to fix that by allowing you to layer refactorings, like you do small scope changes that are connected or tied to some and you kind of you transform across the stack of customizations. So you start with basic boilerplate for the resources, and you can organize your codes to be reasonably scoped. Okay, now we're going to customize this part, and then that part, and that part with these variables. And that ends up being a neater code base that kind of solves a lot of that problem. But it also has a lot of limitations. And it's focusing just on doing this, instead of templating, doing these steps of customization, gradual customization. And it doesn't do lifecycle management at all. Like Customize does not deploy things for you. It just ingests values and ends up spewing out templates, the end result of those customizations. You'll still have to use like kubectl or something like that to deploy things made by Customize, or Argo CD. I know you use Argo. So it's not a complete, replacement. If you want the ability to have an engine that is smart enough to deploy the resources in the proper order, like Customize doesn't even do that. So okay, that was on my mind. Go ahead then.
I would also add that one nice thing that Helm allows you to do that Customize doesn't, I'm pretty sure it doesn't, is the ability to post your charts. So like share your charts with the community. Yeah, just so the rest of the world can also use your chart through the Helm repo functionality. And I'm actually curious about Vince's comment about using them together, because I would think for the sake of simplicity, which I guess, yeah, for the sake of simplicity, wouldn't you want to just use one tool? And when I say simplicity, I realize that goes against the whole complexity that happens at a certain point with Go templating.
Like a very common use case to use them together would be you want to use Customize to as codes for your transformations to the resources, but then you're lacking a solution to deploy them, right? So you can just take what Customize outputs as resources and do like a very in-place local chart to be able to deploy it. Like there's tools to do that, or you can wire them together. And actually, Helm has that post-renderer script that you can call, so you can also layer Customize on top of Helm as an added like sequence in terms of producing the end result template files. So you can actually call Customize from Helm as a post-renderer and do customizations like that as well, which is the inverse order. You go Helm first and then Customize, or you can start with Customize and then use one of those tools that take those templates and do a dynamic chart with them.
Sounds like lots to think about. The challenge I was giving the team is like, I don't want to be repeating, where is the substreams endpoint for deploying, Graph node needs substreams, and the clock API needs substreams, and this needs substreams. These are all the same. So how we template all that stuff. But then, you need Helm charts for these different services because they all work independently, and we're going to have like, I don't know, 100 blockchains with 100 fire hoses and 100 substreams with 300 services on each. It's like the complexity of what we need to deploy here is getting quite huge.
Yes, and I think there isn't a perfect solution yet. There are various attempts at it. The reason why I think it's easy or clear to see there isn't a perfect solution is that you still have like those two camps, Helm and Customize, that see a lot of usage, and also in general, no one is happy with them. There's a lot of complaints. So
I would also.
takes us. Go ahead. Sorry.
Oh, I was just going to say there's another use case I'm also thinking of for Customize, because just like with the blobs and block meta rollouts and stuff that I've been working on, sometimes there's just new stuff that's you've never played with yet. And it's really easy to just, make a deployment, a service, put it in Customize, and Flux CD puts it in the cluster nice and easy. And I would say as like, I don't know, maybe I don't know enough about Helm, but it seems like just writing those two files, making a customize, and it deploying in the cluster for like a dev playing around with something completely new that no one's played with before is really useful. And they kind of already understand it to just deploy something quickly. Okay, we know how it works. This is what makes it run good or whatever. Now we can turn it into a Helm. So more of like a canary before it becomes a Helm, rather than putting all that effort into the Helm when you haven't really played with it yet.
Yes, Customize can start with less boilerplate and simpler. And I think, actually, not towards your point, but I'm going to add, one of the most powerful things on Customize is that it makes it so easy to do like global transformations that you can reuse. Like simple things, say you want to replace all upstream Docker images to like a private local repository, and you want to implement that across all of your deployments. That's very easy to do on Customize. You just do that transform and you use it everywhere. You layer it everywhere. While on Helm, you probably will have to go the way of let's do a library chart and let's do this piece of logic. And now all of your charts need to import that library chart. They need to use kind of the same folks to use that code, right? You need to actively have that in the code to invoke it and to use it. It's more centralized like that. And Customize allows you that power of just doing a simple transformation. On the other hand, if you actually plays a lot with Customize, it's basically about doing JSON patching, which is limited sometimes, like especially on arrays. It's very hard to edit lists of things on Customize because you can't really, it's fairly limited and it's not that speedy development towards expressing everything as customizations, like as JSON patches that you can merge on top. It's not that trivial.
Yeah, I was just more talking in general of just like a quick deployment, just so like a dev can play with it on the dev cluster real fast and be like, oh, hey, it works. And then, give it to me or Gabrielle or Yam, and we can turn that into a Helm chart that everybody can use. Just like as an initial, 5 or 10 minute thing. Hey, it works. That kind of thing.
Yes, but you don't even need either of them to do that. Like you can just directly use manifest that you're editing and applying
Oh, yeah.
with kubectl.
Yeah, but it's not declarative in that way because we use Flux. So if we put it in a customize and have the deployment and the service or whatever it may be, it's all declarative. So that way, the devs I can easily see what the dev did because it's not some YAML they hit apply on their local desktop. It's all declarative in the repo, and I can see exactly what they did. And then my thought is use that to be like, okay, now I can make the Helm chart out of this.
I'm
And I don't have
wondering
to go asking questions.
I'm wondering as an alternative to what you just described, Vince, if you could have like a generic app type of chart that your dev would just have to fill in some values like the image tag, some of the command stuff like that, and use that instead as well.
That would be awesome if there was some type of template where I can say, here's the binary command and the flags, and here's the container image. That would work great. And that would kind of take away that use case.
Basically as an alternative. And yeah, that's what I was thinking, Carlos. We do have a generic app chart. I can actually quickly show it on our Launchpads. You can see my Launchpad chart. You should be, yeah, you can.
Okay, so you have like a generic one for config maps and ingress and
yes. So the app one has a service account, role binding, a pod, or this could be a deployment, like it could be customized to have a deployment. But yeah, exactly like as an example of how you could approach this.
And this app YAMLs for deployments or this one would do the deployment, this app YAML?
So it doesn't have a kind deployment. It has a pod instead, but if there was a need for that, we could add it and just add it as a conditional of if deployment is enabled, then create a kind deployment kind of thing.
Yeah, so we'll just need to probably we'll probably because there's something we usually use everywhere. It's basically a deployment, a config map, use sometimes a secret, ingress, and service, and a service monitor.
Yeah, you basically can tweak or personalize a chart, which takes as few values as you can get away with for dev to use. That quickly allows them to have this. It will be limited, but well, it will only be limited by how much logic you put into it, right? Into terms of templating and options. But it's feasible, and you can do that. We do have some criticism on like the hardships or the trade-offs of Helm Chart as well, further ahead on the presentation. So maybe you want to resume that, Anna.
Sorry, maybe I want to what? I can go there now.
Resume the slides.
Yeah.
Oh, okay. Okay, so like code templating in Helm, the thing with implementing logic in Helm charts, or one of the trade-offs that leaves people unhappy, is you can have some utility, especially because Helm has the Sprig library, which you may be familiar with if you've done some Go templating. But it does take some getting used to, and I do feel like it doesn't make it that easy to produce organized, like readable code. Like the basic construct is using functions on pipelines, like that example, you go like function, parameters, and then a pipe symbol, more functionings, and they in turn transform some type of output or variable or text to a different end result. But you can't really define functions, your own functions, to organize your code. The best you get is something which is more akin to macros. You can define blocks of templating, and then you can include them right in place using the include keyword. And that just kind of works like you can't get variables or treat it as functions. It's just purely macros. And that doesn't lead to that neat type of organizing your code. That's why it becomes so easily. It's like such a mess. As some good to knows, when you want to get values out of something like that, those values need to be in the output of your macro, right? So if they are complex values, you're probably going to have to use the function something like toJSON to output them as JSON, and then somewhere else you're going to include that macro, and you're going to take that input as like from JSON and map it back to variables. And you need to repeat that everywhere you're going to include. There's a life of those basic constructs that you'll have on a programming language because it's just a templating language. So it becomes not as elegant to work with to build complex logic. Let me see more points there. It does expect you to every line of coding you're doing on Go templating that it's going to produce some kind of output. So you have to use those minus signs on your curly braces a lot. Curly brackets, sorry. To suppress those lines, or otherwise you're going to generate a lot of empty lines. And there's another gotcha, which is the loop keywords like for and with. They automatically use local variable scope. So say you want to do some kind of a loop with for, and then you want to create a variable or assign a value. You got to be very mindful of that aspect of it. You need to declare it outside of the loop, and then just assign the value. And to confuse things, Go templating uses different syntax for declaring a variable and assigning a value to a variable that has been defined before. So you need to be like very mindful of all of those components. I think it's a bit, to be honest, I hate doing Go templating. It's not elegant at all.
I also don't find it particularly easy, but I will add that once you have a good, reliable template, like a good, reliable approach, it becomes a bit easier. But yeah, thank you, Carlos, for covering all of this. And we'll show in the code some more gotchas and stuff like that. All right, so going back to where we were, so Helm charts So Helm charts are template definitions. They allow for parameterization through the values and can be customized for different deployments by overlapping values, and also by enabling one chart to support multiple environments or configurations. They can be versioned, which makes it easy to roll back to a previous version, and they can be shared with the community via Helm repository. And as well, they allow for dependency management by specifying dependencies on other charts. So if we quickly look at the directory structure of a Helm chart, so if I run Helm create Eragon, so I'm naming my chart Eragon, by default, it would give me this directory structure. So it has a Helm ignore, which is just patterns to ignore when packaging. It has a charts.yaml, which includes information about your chart, so version name, description, the values.yaml, which defines the default values for your templates, and then a charts directory, which can be used if you want to define subcharts to be dependent for your charts to be dependent on. And then finally, the templates directory, which is where you define the resources, Kubernetes resources you want your chart to install. So if we look at the deployment.yaml, HPS horizontal pod autoscaler, ingress service account, etc., those would be examples of definitions that are created by default with Helm create, so that you get a starting point of your Go templating journey. You also have important helpers.tpl, which is where you define those macros that Carlos mentioned earlier, which can be reused, and then just some nodes. And there's also a directory for tests if you will be supporting tests. Some comments on where we are with Launchpad charts. None of our charts use subcharts, and we haven't yet added testing, but we will add testing at some point. Okay, so that's what you get when you run Helm create. But for the purposes of today, I need to switch my screen. No, you can see it. So for the purposes of today, we've created a read chart, so a Rust Ethereum chart. And I'm just going to go through some of the files here. So starting from chart.yaml, this is very similar to how all of our Launchpad charts have been defined, but you can see here you have an API version, you have the name of the chart, some description, the type of the chart. So here type is application. The other type can be library charts, which provide useful utilities and functions for the chart developer. We will talk a bit more about those library charts. And then you have a version which is needed for each chart. For our Launchpad charts, we have a version of the actual chart and then version, app version, which is how we have plugged in with Renovate to get automatic new charts when new app versions are set up. So the app version matches with the image tag of your whatever you're installing of your application. All right. Looking here at helpers really quick. So some of the things defined here. So for example, we have a read name, which is the chart name with the values override. We have a full name, which creates a fully qualified app name, and a few other, like for example, labels, selector labels, a service account name, so that instead of having to type every time value service account name, you just give read service account. And yeah, a few other functions that have been defined here for reusability. Now, in terms of what read would need to run, so it would need a stateful set, and this is how it looks like. So if we start from the beginning, we have added JWT functionality. So so in order to run read, you need to pass a JWT. JWT should be stored as a secret. This chart specifically allows you to create a secret from an existing secret. Allows you to create a secret if you don't pass it an existing secret. This is needed later on in the chart, and then we have all of some of the so read full name, which is what was defined in helpers. Read labels also defined in helpers, and selector labels as well. So yeah,
can I just
go ahead.
comment on we have good examples there about how it kind of ends up working in templating with that whole includes that we're basically fetching a macro from helpers, right? And it's basically output based. In this case, the one you have highlighted is there, rest.replicas just returns a small bit of text, which is the number of replicas, but above, for instance, labels can be a whole section of labels, right? It's a list. And you're just including it, and then you have to take care of passing it through the indentation function, which is to, like, that macro is going to return several lines of output, and you need to indent them to fit at the right indentation and the labels. So you need to take care about those small details, because anything you can pass around on these macros is just text. That's all you work with. So it becomes a bit cumbersome. Yes, the include keywords is basically invoking the blocks of templating you've defined with the defined keywords. You can use define and that includes. When you use define, you name them. And if you go to helpers, you'll see there's all of the sections that are basically start with define and then some name. And then later on, you can include based on that name. The name is just a string. But there's no like variables or stuff like that you can import from other files. It's just the engine basically just replaces that include with that block of macro, and it's just text. You have to take care of indentation and all of that. And if you want to map it back into variables to use in logic, you'll have to use things like to YAML or from YAML and like just, yeah.
Thank you. Those are important to mention. Then another interesting pattern, really useful pattern actually, is the ability to add conditionals. So for example, adding if loops. So for example, if you want to add priority class name, or if you enable P2P node port, then you would add this init container that goes and fetches those node ports, those details that are needed to enable node ports. You can use the if conditionals and the Go templating at command level as well. Let's see what else. I think those are some of the main stuff. Wanted to briefly describe the, so Vince asked about how can we import, like store JSON dashboards as code, and then how would we put those how would we manage those? With Helm, you can do it as a config map. So here we have a config map that we have a config map that if Grafana dashboards are enabled, it will check for files in dashboards, so in this dashboards directory, and it will import all of them as a glob. I'm just waiting for the people are typing. Actually, while we're waiting, one pattern that we're using a lot with Launchpad charts, I haven't added it in this read chart just for sake of simplicity, but the pattern we use a lot is having a chart with multiple components. So for example, Erigon uses a component called RPC daemon and installs a component called RPC daemon and a component called stateful node. So RPC daemon installs a deployment, a service monitor, and HPA, and the stateful node needs a stateful set, a JW3 secret service monitor. The way this is defined is using something called component names, and the difference comes in values where it's a bit nicer to define from a readability point of view. So for example, okay, I have the component stateful node. All of the values related to stateful node are defined under are separated from each other, so it's easier to read. And yeah, this is a pattern that sort of groups different resources that are associated with each other together in a nicer, more readable way. Just 1 second. You can see the same with Prometheus chart, has a lot of components. So each one of its components are grouped under templates, basically a similar pattern as well. And one more thing to mention in our side, there are the components, so the resources that are related to each other, but then there are other resources that are more global, and those have been defined directly in templates. All right, back to KPT tries to address the whole Helm pros and cons and customize pros and cons, and what is not addressed by either by going in a way that treats processing resources through a pipeline. So you can engineer pipelines that will make use of Helm, customize, or anything else you may want. I think Erigon is conditional in creating a JWT. Let's see.
That would be turned on in the values YAML, right?
Well, it's conditional on having that from literal, for instance, set. So if it's an empty string, that if will be false, and it doesn't even create a secret. So
yeah.
Yeah. Okay. So we had a brief look at the read chart and some other, like briefly talked about some patterns. One more thing that we have that has been useful is a resource injector chart. So all this does is allows the user to define a chart. So say you need a specific resource like a secret or an ingress resource that you want to manage outside of other charts, but you still want to have as declarative. In that case, we've created this resource injector, which allows you to basically define your resource and deploys it as a release. Moving on to let's install this read chart. So Helm needs, if I run Helm install read is the name of the release, and the location of the chart is charts read because it's local, but you need to add the repository if you want it to install directly from a repository. And then the namespace I will go with is read.
yes, we do use resource injector a lot. And it's just a very simple wrapper. Like Anna says, you give a YAML of a resource, and boom, you have a Helm release around that. It's very useful when you want to do things like create a Postgres database with the operator, where you just need to inject that. And PostgreSQL with CRD, right? Like loads resources like that. It's useful, and we do use it a lot, for instance, on namespaces, where you have that conditional creation of some types of resources, and so we have this dynamic chart around it. It's very useful.
So this is
Thank you,
basically just
agreed.
like a post dot. Like you deployed your Helm, but you're like, oh, I need an ingress for this and this namespace that's not part of a Helm. I'll just add an ingress there real quick. That kind of thing, or that kind of use case.
Yes. Yes, you can, if you can, like on Helm, say on Helm, with Helm file, like on namespaces, you can template the YAML, and then you just invoke this resource injector where you pass that as a value, and boom, you have your extra resource as a release of its own that you're now being able to deploy with Helm file.
And just to add on what Carlos said, yeah. So ingress is one of the use cases we've been using it for, but the main one, I think the most important one, is defining Postgres database, Postgres cluster resources, which create Postgres databases that are read by the Postgres operator. All right, so I'm just gonna go ahead and install this chart that I have here. I have already created the namespace. So you can see here that there are no pods in my cluster. So if I install it and everything goes okay, it should work. But actually, before I install it, just want to quickly show that you can do something like template to show to check that your chart has been defined properly. Let's see, and you get an output like this that is basically YAML that goes through every single resource it would install if you run Helm install. But if there are any issues with the chart, it would error out. All right. So let me run Helm install read read. Okay, so this is running. Yeah, this is we don't need to talk about the application itself, but the node has started running and syncing. And if you are to look at Helm status, read, it will tell you basically the same as the first status, but if later on you had issues or you wanted to see if there's anything wrong with your chart, you would be able to see that. You also have Helm history, which is useful for details around your installation. And I'm just gonna run this with a different chart that I had earlier. Okay, I don't have any more state. I think I deleted the previous chart. But you would be able to see every single release that has been the release that has been installed, and then every single iteration of updates that have been applied to it. Just quickly checking the chat, so no specific integration with other tools.
Let me just do a quick comment on how that history works. And I think that under the hood aspect of Helm is worth knowing, which is every time you do a Helm install or upgrade, it packages a lot of metadata about what it installed and what the values it took were, and creates a secret or a config map. Anna mentioned that right at the start, but it does create you a secret, which is encapsulates all of that in JSON. And that parameter about for the history is about how many of those secrets it retains, versioned, like steps. You can configure that on your Helm configs. And it's important to have in mind that's how that works. So if you manually change a resource from the point of view of Helm, it doesn't know. Like it doesn't actually go check live resources on the cluster or compute if there's a difference, right? It doesn't do that.
And those
it doesn't
changes.
reconcile. It doesn't reconcile. And even plugins like Helm Deal will just look at the current template that it's outputting if you change your values versus the last deployment secret, which contains how it was deployed. It doesn't do actually live resource inspection.
And if you did change anything manually, it would be overwritten next time you run a Helm upgrade. And this is the way to get your secret, like details about the secrets. They're all in the same namespace as this is basically the state, same namespace as the resources, the release itself. All right. I'm not aware if there's anything like Renovate for KPT. Carlos, do you know?
I don't, but Renovate does have the reject engine, which is very, very flexible. So I feel like I'm going to say with a bit of work, you can use Renovate even without like a trim. support, like without specific backends for it, for the particular format, you get a long ways with regex. We actually use regex because even the Helm support for Renovate isn't that complete in practice. So we mostly rely on regex.
Thank you. Okay, just super aware that I have a few minutes, so I'm just gonna quickly go to the rest of the slides. So just some basic commands. So you've seen create, you've seen install or upgrade, which install installs a new chart, upgrade upgrades existing release, but you can also install a new chart. Then delete or uninstall, they're interchangeable. Uninstall is the command preferred in Helm tree. And then Helm list A lists all of the releases in a cluster installed in all of your namespaces. In terms of troubleshooting, so you have Helm lint, which identifies syntax errors. You have Helm history, which gives you revisions of a release. We briefly touched upon it. Helm template, you've seen it, and then Helm status, which, yeah, they can be super useful if you're having issues with your charts. We touched upon Go templating limitations. Some other features. Plugins. So Helm supports plugins. In our Launchpad setup, we use the diff plugin, which previews the Helm upgrade changes as a diff. And we also use Helm Git, which allows Helm to directly install charts from Git. Additionally, in Helm tree, library charts have been introduced. So a type of Helm charts that define charts primitives and definitions, which can be shared by Helm templates in other charts. So while Launchpad charts doesn't yet use library charts, we plan to use them in the future. One place where we could use them is to reduce duplication of some of the definitions in helpers for each chart. Another cool feature is the hooks. So hooks allow for custom management of the lifecycle of a Kubernetes resource. So for example, setting dependencies, managing configurations, or cleaning up resources. Commonly used hooks are pre-install and post-install for actions before and after chart installation, pre-delete and post-delete for actions before and after chart deletions, and pre-upgrade and post-upgrade. An example of where you could use pre-install hook would be to wait for a secret that your deployment or stateful set might be dependent on to be created. And hooks are commonly used in databases, for example, for restore actions, and so on. All right. Next thing. Oh, and test is the last thing. So they are under the hood implemented as hooks, and they allow you to specify resources that are meant to test if your deployment is successful and if it works. And then there's a bunch of resources. So the Go template, some Go template example, a link to the Sprig library function documentation, and then more details on hook. Okay, so question. So we use library charts for defining substreams for all the things that are built on top of substreams.
Yes, can you clarify that question, Matthew? I'm not sure I'm understanding the question.
It was more a question to Gabriel.
Yeah, I feel like when you're saying you like library charts have nothing to do with doing charts for libraries. There may be some confusion there. I'm not sure I totally understood your question.
No, I just mean we have a lot of so we have substream sync Prometheus, substream sync Discord, substream sync Telegram, substream sync whatever. So you could create a chart for each one of those, but they all look like almost the same. So presumably you could put all the stuff in a library, and then all your Helm charts would look the same. That's what I mean.
Yes, we'll reuse a common trunk of code or a common trunk of logic. Also makes it easier to get. Sorry. Go ahead. Yes.
Oh, I was just gonna say that seems like it would be more so like one Helm chart with a little more defaulty value. So you just have one value CML, so you can turn it into kind of whatever you want with one Helm chart. If it's sort of similar.
Maybe.
You can. Yes, you can also do that. The advantage of that is that, like, okay, how do you version them separately? Like, are you going to have a repository for each? So are you going to be duplicating that Helm chart across all the repositories? And then when you want to change it, like that common Helm chart, where do you change it? That's kind of what library shards are for. I think you'll still want to use one because you want to make them independent so that you can version them separately, but you want to import or reuse like a ton of common code.
Yeah, sounds interesting.
The subchart would cause a lot of duplication because the subchart is specific to a chart. So so it wouldn't be something else, something that can be reused outside of a chart.
You can also, yes, you can. I think you can also take an approach with subcharts, thinking about it. But I think it has its own drawbacks, pros and cons. Like subcharts mandate that they need to come in a subdirectory, right? So say you want to host them on Git, you're probably going to use what's it called, submodules, Git submodules. Or you pull them in as a dependency.
Maybe another session on libraries versus subcharts.
Yes. Any
So
questions? The Kubernetes, do you want to take that, Anna? I was going to answer.
I'm not probably gonna give a full response, but one difference with pod lifecycle tools versus Helm hooks is that Helm hooks are not automatically deleted, so you have to add additional deletion strategies. So, for example, post delete type of hooks. So that's one example. So they're managed slightly differently, and yeah. What were you gonna add, Kyle?
I was going to say that like those Kubernetes hooks that you can use, they do need to come, they're a permanent part of the deployment, right? Like because they need to be included in the templates Helm is generating. So they're treated as part of the thing you're deploying, you're putting that logic there, while Helm hooks allow you to inject logic into, let's say, the orchestration flow, where you're not changing the templates of what you're deploying. Meaning, if it's an operation you want to do as deploying, say you want to hold off deploying a stateful set because you want to make that job wait for something else to be created. and you can inject that logic on that orchestration flow on Helm side by, okay, you're gonna create a pod, and the pod is going to sleep and wait for that. But that pod will be gone after it's deployed. Like, you're not transforming the resources you're deploying. You're keeping those concerns separate. So while to leverage the Kubernetes ones, it means transforming your end result of what you're deploying. And you're constrained to also be on that Kubernetes flow. You can actually use hooks to impact changes on Helm from the Helm point of view, like outside of the scope of Kubernetes. Actually, for instance, transform the resources. For that, you'll use like post vendor, but yes, there are use cases like that. Or to upgrade CRDs or do some change like that.
I'm aware of the time, so I wanted to ask if we want another session on this, and if so, what should we cover? Like, so Matthew, you just mentioned more details about the libraries versus subcharts. What other topics can we cover around this if we want another session?
I think now that we have kind of an overreaching view of it, maybe just like building a simple Helm chart, just like a live building of a Helm chart would be cool. Like creating it, writing it, maybe even something simple like just like an Nginx container, just writing like a default template and then like creating it and then like publishing it and launching it basically. I don't know if that could be covered in an hour. I don't know how long it takes.
Yeah, so our concern with that was that for doing a good example, it might take longer than that, but if we do something really simple, we can definitely do that.
Yeah, it was especially limiting if we wanted to cover like the whole intro and session and then actually do that as well. It would be a really small time window. But if we do a session just around that, I think we can go some ways in the time slot. Because it's different. We don't need to go through all of this intro stuff before. You can just focus on that. If no one has any more questions, I'm going to also plug in another project. Matthew and Gabriel and Vince, the UPNX guys, I think may be interested in looking at this. Which is kind of a scripting language. Also suffers from not massive adoption on the ecosystem, although better than KPT. We actually adopted that one from namespaces. It does have some uses. And I really, really like it. We ended up using it, like I said, in namespaces where the Helm files are actually programmatically generated, and the logic towards generating them is built using Q. Q will be an alternate approach to, like templating resources. It does a very good job in terms of allowing you to build for validation and schemas and stuff like that. The thing with it is it takes a while to wrap your head around it. It's not a Turing complete language, and it's certainly not the common paradigm in terms of programming. So it takes a bit of getting used to. Other than that, I do feel like it has its place in this whole pipeline of transforming and manipulating or validating Kubernetes resources. and actually there's been some adoption. Viral. Yes, Matthew.
Okay, thank you for joining, everyone. Speak to you next soon.